Distinguished participants, first of all, we would like to thank you for taking your precious time today and participating in the second event organized by the Ministry of Energy and Natural Resources, the workshop on data management and digitalization in energy generation and planning. As we stated at the opening of the battery storage workshop on April 21st, although we can't physically get together with you today due to the COVID-19 pandemic, we continue to maintain our solidarity and dialogue in digital environment. We hope to come together as soon as possible. For those who couldn't attend, you can access the recordings of our workshop organized on April 21st through this digital platform until May 29th, 2021. Dear participants, as we all know, in the process of accession to the European Union, various projects are implemented across many different sectors in preparation for membership. These projects are co-financed by Turkey and the EU through the Instrument for Pre-Accession Assistance, IPA, within the scope of the Turkey-EU financial cooperation. As the lead institution in the energy sector, the Ministry of Energy and Natural Resources is responsible for the programming, implementation, monitoring and evaluation of the EU-funded projects. In this framework, the Energy Sector Phase 2 program has been carried out within the scope of the 2013 program, co-financed by the EU and Turkey, and in cooperation with the World Bank. The program will be completed on May 29, 2021. As you know, the Phase 1 program was completed back in 2017. Within the scope of the Phase 2 program, many projects have been implemented in the fields of energy efficiency, energy projections, and the development of energy markets. As the Phase 2 program is drawing to a closure, we are hosting events held on 3 different days in 3 separate weeks within the scope of this digital activity to present the outputs of the projects in the fields of energy efficiency, battery storage, and data management and digitalization in the energy sector, and to share information on global developments across the fields explored in the projects. Today, we are pleased to be hosting you, our distinguished participants, at our second event, Workshop on Data Management and Digitalization in Energy Generation and Planning. Digitalization in the energy sector, big data management, and energy projections are milestones for the future of sustainable energy. We will listen to our esteemed guests about the importance of digital technologies and data management in energy planning and production in our workshop today, which will last until 12:35. I wish you all a very productive and pleasant workshop. Without further ado, I would like to start the first session and leave the floor to our speaker. Our first speaker will be Mrs. Çınla Demircigil Akkaşoğlu, Energy Balance and Modeling Coordinator at the Directorate General of Energy Affairs of the Ministry of Energy and Natural Resources, who will be delivering a presentation titled Establishment of Energy Data Center and Long-Term Energy Scenarios and Capacity Building. The floor is yours.
Hi, I'm Çınla Demircigil Akkaşoğlu. I am working at the General Directorate of Energy Affairs at the Ministry of Energy and Natural Resources in the Department of Energy Supply Security, Markets and Statistics. And I work as the Energy Balance and Modeling Coordinator, and I am going to provide you with information today about the establishment of the Energy Data Center and the long-term energy scenarios and capacity building projects. We are going to be talking about the significance of data, data management, our general balance charts. Now, of course, the significance of data. Now, as you can tell from the name of our project as well, data is very important for us. Now, for all of us, data has become very important. For many of our indicators, analyses, the source comes from the data. So to be able to transparently see the current situation and to make accurate and precise decisions for the future, data is very important. And it also helps for concretizing the many abstract concepts. And of course, the technology, the changing conditions, the competition situation, and efficient decision-making processes also require more data, and this increases the data volume and the data flow. Now, of course, data doesn't mean anything on its own. It needs to be processed and turned into information with significant meaning. And of course, with the increasing amount of data and the integration of this data based on needs, we can make the data more significant, and that's why data management becomes more important. Now, data management enables the data to be collected safely, efficiently, and cost efficiently based on needs, and then it is analyzed, standardized, and it is made available for utilization. So the raw data that is collected is turned into information with significant meaning, and that's why it is, again, very important to be able to manage data. And with efficient data management, we are able to categorize data, store it, and increase our analysis capabilities. And of course, data security and control of data flow is very important, and that's why organizations are starting to set up big data centers. And these data centers are places that are set up with huge hardware equipment to collect data. Now, how important is data in the energy sector? Of course, the energy sector is a very important sector. It's very dynamic, it's constantly progressing, and it's integrated with many sectors. And from the supply to the very last point where the demand is met, of course, we have many indicators. And of course, in the energy markets, we have seen great momentum in the recent years. And in parallel to this, there was an increase in the data volume as well. Now, of course, there's an important economic motto. There are infinite needs, but finite resources. Energy is similar to this. So we are targeting optimum use with limited resources. Of course, the energy sector is a rapidly changing and developing sector, and decision-making is a very challenging process in such a sector. So data and data management becomes even more challenging for decision-making processes, so it's something that we need to be able to manage. So in our Directorate General in the energy sector, what kind of data are we involved with? Now, of course, in terms of following the statistics, following the supply and demand situation, and looking at the market and the grid developments, and to be able to make some forecasts, some weather forecasts that impact the supply and demand, and to be able to forecast the short, mid, and long-term demands, and to be able to run modeling activities, to create various indicators, and for pricing, of course, data is very important. In terms of political targets, again, to be able to make the necessary plans, to conduct risk assessments, to evaluate the possible risks and their impacts, and creating an inventory of the energy resources in plants. We need data once again. And for that, of course, first of all, we need to be able to generate data. Now, first of all, we have an activity called the General Energy Balance Charts, GEDs. And these GEDs are basically used by many countries across the world which have an intense flow of energy. So the manufacturing, import, export, stock information, and energy consumption data based on sector is collected on these statistical charts. And we then look at how this energy is utilized and how it is transformed into other things. And we see all of this in these charts. And basically, it's a chart which has a great volume of data. And we create the energy statistics in tabular format. We design it and make it meaningful, and then it becomes a data that we can compare with other countries as well, and also for supply security, for national market development assessments, to make accurate decisions. All this data becomes very important. So, what are the legal grounds for this activity? In the mandate of our Directorate General, we are in position to make all the necessary plans to meet all types of energy needs of the country and to keep the inventory of the energy resources. So how does the process continue? Well, we carry out these GEDs annually, and we use the data of the previous year. Now, first of all, we evaluate the changes that occurred in the sector in the previous year. Of course, we analyze this, and we also gather data from parties in the sector. We hear about any progresses, any shrinkages, any innovations in the sector. And then we get the company list from the Turkish Statistical Institute. We look at the ISO lists, and we look at our previous framework, and then we create a new framework every year. And with this new framework, we identify the parties who we will send questionnaires to. Then we review the questions to see if we want to add any new questions, remove any of the former questions. And then after that, through the questionnaire management information system, we assign our questionnaires. And then, of course, we control the incoming data. This is very important because for the data to be accurate, we need to control it efficiently. And that's why this is a very important process. And in this way, we are trying to create a supply and demand balance with the sector based on fuel needs. And we complete our projects. So what are the usage areas of our GEDs, our general energy balance charts? Well, this data is very important to understand the greenhouse gas emissions that result from fuel consumption. And also, we use it for calculating various national and international indicators like energy intensity, energy and electricity consumption per person, the energy supply and the shares in electricity generation, our foreign dependency and energy consumptions on a sectoral basis. And it is also used for other areas. I mean, it's used for sectoral reports, energy efficiency indicators, for Eurostat, for national greenhouse gas emission calculations and academic activities. It has a lot of input for us, basically. So if we are to talk about international question forms, the questionnaires, we collect a lot of data through our GEDs, and with all this data, we provide input for many international questionnaires. So we actually send these questionnaires to these international institutions, and they basically create a balance builder. They use a balance builder, and they create the world energy balances. So we are able to acquire many statistics with these activities. And basically, our GEDs are very important, both at the national and international level. So if we are to talk about our data sources, of course, we get administrative records from our stakeholders, but we also have our questionnaire approach. So what does our questionnaire look like? Well, our questionnaires are prepared based on the statistical classification of economic activities in the European community. They're all in compliance with that, so our data is collected accordingly. And we send questionnaires to 4,200 enterprises, and we also acquire data from around 200 import companies and other public institutions. And in line with the responses we receive for our questionnaires, we create our statistics. Now, if I am to show you an example of a questionnaire, what kind of data do we collect? Well, this is an example of a questionnaire of our new system. We have three sections. In the first section, we ask about the semi-finished products and products for each plant. And then we then ask for information about the two products with the highest revenue share. And with this, we will be able to have a cross-check between the years. And then if we have the second and third parts, in the second part, we have the fuel procurement information. So basically, which fuel does the plant use and how much of it does the plant use to be able to produce the products listed in the first section. And then in the third part, we see how much fuel they use in the cogeneration plants, because those will not be part of the calculation. We get data for that from TER, so that's why we want the plans to sort this fuel utilization accordingly. And after all this data, we create our final chart. And here we see the original units of each item, and we also see the tons of oil equivalent amount here. And we are able to see which energy is converted into which one. And in the final part, we see consumption based on sectors. At this point, of course, since this is a very data-intense activity, we had a system requirement, and we carried out a project in this framework, the establishment of the Energy Data Center. Now, of course, we had already stated that a lot of input is created with the GEDs, and to get significant meaning out of this, we need to manage data accurately. And when we look at the history of our balance activities, we can talk about three different periods. We have the pre-2015 period, then 2015 to 2018, and then the post-2018 period. Before 2015, we would physically send the questionnaires through the Postal Service, and we would get our responses with physical letters and emails. And we would have data entry into Excel and analysis and reporting on Excel as well. In 2015, we had our web-based internet portal system transition, and this was very beneficial. We didn't have to use the physical postal service anymore. We were able to assign questionnaires on the system, and we got our responses through the system as well. And we were able to have first-level pre-controls or pre-checklists, and this was innovation for us, but we still had some technical restrictions. We still weren't able to increase the volume as much as we liked, and we also needed some high-level controls. So for that reason, we had a new project in place to renew our system. The project that we are talking about is the establishment of the Energy Data Center. And in 2019 May, our project was initiated. And then with June, we identified the deficiencies in the existing portal systems and our expectations in the new portal together with the company. And we identified our requirements. And then with the software development process being initiated, we needed to have a migration of our data from the previous system to the new system. And we completed that. And then in 2020, as of May, we completed our migration process. And the testing, of course, took a lot of time. We had some findings about the basic system requirements, and these findings were then attended to by the company. And then by 2020 June, with our new questionnaire management information system, the system was live. And of course, we had some additional items, new findings after the go live. And then the software development continued, and then on the 31st of August 2020, the project was completed, and it started its maintenance process, which would last for 2 years. In 2019, we sent, in 2020, we sent our questionnaires for 2019 through the system, and we are continuing our activities for this year, and we will soon be assigning our questionnaires. What else did we do as part of this project? We talked about data centers and the importance of data. As part of this project, There were 16 servers and one data storage system installed in the ministry building. And also we had a disaster recovery, one server and one data storage system installed at the disaster recovery center. So what did all of this provide for us? What did we acquire? Well, the data center established for this project is quite a comprehensive one, and it was very positive for us in terms of data efficiency and data security. In terms of software, we are able to send the questionnaires with email, and we can send user credentials through email as well, and we can assign questionnaires over the system, and we can receive responses through the system as well. So it created time and paper saving for us. And we were able to set more advanced control checks, and the improved technical and system capacity enabled us to increase our questionnaire volume and our speed, our system speed. And of course, this provided us with the opportunity to increase representation in our questionnaires as well. And we are able to design various types of questionnaires with different contents as well with this new system, and we can design different types of questions, chart questions, multiple choice, single choice, and open-ended questions. So we have these new opportunities as well. And another contribution it had for us is to be able to integrate some external variables like population and GDP information. And these are inputs for our models, and these will be positive for our project as well. And also the reporting of the data in a timeline is beneficial for us. We have different types of reporting options. We also have province-based data, which we didn't have before. So we are able to see province-based data on the map. And our final balance report can be created on the system in various units from now on, and this enables us to create different types of reports. And of course, there are two sides of this software. There is the admin part and the user part. On the user part, there is the instant ask question feature, which was added. They can ask us questions instantly, and there is also some how-to videos about the system. So when they get stuck somewhere, when they don't know what to do, they're able to watch these videos. So this was quite user-friendly. And after this new system, of course, it contributes to another project as well, to transfer data to energy planning and modeling. This was very beneficial as well. So if we move on to these activities, now why do we need energy planning and modeling? Why are we running these activities? Well, the energy sector is very dynamic, as I said. It is progressing rapidly. It is intertwined with many other sectors, and in terms of sustainable development, in terms of development, it is very important, and the changing technologies, fuels, prices, political goals, the changes in preferences and behaviors. We basically need to be able to forecast the uncertainties of the future, and for us to be able to make conscious decisions and to be able to review the future demands and to be able to meet these demands, energy planning and modeling activities are very important. And again, evaluating alternative options to find different ways to meet the needs, to be able to forecast the risks, to identify the benefits, to be able to test the efficiency of political measures, to be able to manage compliance with environmental restrictions and climate targets, and to be able to identify investment requirements. Again, planning and modeling activities are very important. So basically, to be able to comprehensively and transparently prepare for an uncertain future, we find it very important to run planning and modeling activities. So what did we do as part of our IPA 2013 long-term energy scenarios and capacity building project? Well, we started in 2018 October, and we used the mathematical infrastructure of the primes model, which was done as the EU reference scenario 2016. And the energy system model for Turkey was created based on the primes model. And as in the scope of the project in 2018 December and 2019 January, we had basic trainings provided, which lasted for 1 year, to personnel from the ministry institutions, other ministries as well, who were involved with the energy sector. And then in 2019 March, we received training on GAMS. And in 2019 December, we received education or training about the other modules, which were about biomass and balance modules. And we worked on alternative scenarios rather than reference scenarios in the trainings in 2020 February. And then we shared our reference scenario results, updated reference scenario results. And then in 2020 June, we had our base year calibration. And then we received our advanced level applied online calibration training. And in 2020, we addressed the uncertainties in hydraulic production, the seasonality, and the interrupted renewable energy generation. And in 2020, December, we received training to see different codes on the GAMS documents, to analyze the model errors, and to be able to forecast the challenges we might face when we want to add something in the future to these documents. So we received various applied trainings, and at the beginning of the project and towards the end of the project, we looked at the structure of the institutions in Spain, Belgium, and the Netherlands, and we conducted some field visits to see the energy planning activities and the existing implementations there, and it was very beneficial. So to talk about the EST model a little bit, the energy system model for Turkey, in a term, it has different modules, demand, balancing, cogeneration, and biomass. And it was a tailor-made model for us. We have macroeconomic indicators here. These are auxiliary indicators or variables. And basically, our macroeconomic indicators as auxiliary indicators are part of the demand module, and sectoral models are reviewed again and again until the pricing of the market is acquired. So what is the EST model? Well, it is actually a market balance model. Mathematically, it's based on GAMS, and all the inputs and outputs are through Excel files, and there is a very intense data flow. We have a lot of data in the Excel medium that is an input for the model. And in the end, we receive a wide array of outputs from this model. And we are able to forecast energy supply and demand until 2070 with 5-year periods in the fuel and sectoral-based energy in fuel and sector basis. And the model is also offering the most cost-efficient solutions. And when we have our supply inputs and demand inputs, and if we look at our supply inputs, we have plant-based inputs mostly, and we have all the existing and planned power plants. We look at the gross and net capacities, their capital expenditures, their minimum working times, their downtimes, and we look at storage, the maximum charging hours daily, and we have system information like reserve type and requirement, fuel prices, the import exports, voltage levels. We have resource-related data, maximum fuel amount, maximum hydro resources, and the also we look at various models like industrial steam generation, so it's very comprehensive. And then we also have political data, fuel-based taxation, tariff guarantees, the plant working hour restrictions, environmental policies, emission trade system. So all of this is also inputs for the system. And then when we look at the demand inputs, we look at the scenario forecast, macroeconomic factors, the international hard coal and lignite, hard coal and crude oil and natural gas fuel prices, and added value based on sector for all sectors and the potential amount of fuel and resources. And for political data, again, we have fuel-based taxation, carbon price, carbon value, energy efficiency value, technological and fuel restrictions. So we have a lot of inputs. And if we are to continue, again, population, GDP per capita, so macroeconomic indicators, again, are used as auxiliary indicators. And banning of fuel as an input technology use being banned. This can all be changed, and equipment based on technology type, technology equipment subsidies based on technology, fuel-based CO emission factors, biomass and hydrogen additional costs. So we have a lot of specific inputs. But differing from all these specific inputs, the model is basically based on the GED charts. So most of the resources for this model come from the GED charts. And when we look at the results, what do we receive as results when we run this model? We have very comprehensive results, primary energy consumption based on fuel, national production, net import based on fuel, sector-based CO2 emissions, sector fuel-based final energy consumption, energy intensity, carbon intensity, and we look at fuel consumption based on sector and carbon intensity and energy intensity, the investment costs, the system costs based on sector, the plant type technology and fuel, the production costs. So we receive comprehensive results. So what did this project provide for us? Well, of course, we were conducting modeling activities before as well. We used various models. We used different models from time to time. But this project is very important for us because it's tailor-made. So yes, we are using the mathematical infrastructure of the primes model, but we came together with the experts many times, and we looked at the energy sector and dynamics of our country in detail, and we were able to create a model that would reflect our country's circumstances. So we have our tailor-made model for the first time, and we are able to conduct detailed analyses. So that's why, as a tailor-made model, it is a very successful project for us. And then we had trainings and field visits to countries. We received a lot of training, and in general, the trainings were about the modeling infrastructure, different models, what types of models were used abroad. So we improved our knowledge, and we were able to visit countries and see some implementations on site. So our corporate capacity building benefited from this. And also in terms of international standard compliance, we have important indicators for environmental factors, for example, and this is all going to be very beneficial for us as well. And for our political goals, we are to be able to conduct risk assessments. We are able to conduct comprehensive and detailed analysis in many areas, and we can focus on different scenarios. So after the reference scenario, we have developed 3-4 scenarios, and we are continuing to work on them. We are changing our variables, changing our political targets, and seeing different scenarios, how they would play out. And we are also working on the 2020 electricity demand projection model, and we used outputs from this model in that, and that was a new development for us. So I believe this was an important development for us. That's all I'm going to say. Thank you for listening to me, and I hope it will be a fruitful workshop. Thank you.
We would like to thank Mrs. Çınla Demircigil Akkaşoğlu for her presentation. Next, we will hear from the Senior Customer Relations Manager of Koç System, Mr. Caner Kaptanoğlu, delivering his presentation on the establishment of Energy Data Center project. Mr. Kaptanoğlu, the floor is yours.
Hello. As Koç System, we are very happy to be with you as part of this event. In today's presentation, we are going to be talking about the project that we realized as part of the IPA project jointly with the World Bank and the EU. And it's titled the Questionnaire Management Information System. And furthermore, we will be talking about the projections towards the future of Koç System. So I would like to briefly introduce myself. I'm Caner Kaptanoğlu. I am a senior customer relations executive at Koç System. In 2003, I completed my bachelor's degree in industrial engineering at Başkent University, and I completed my MBA in marketing and sales at Bilkent University in 2005, and I've been on my career journey for 18 years. And since 2017, I have been working as the Senior Customer Relations Executive in charge of public energy sector. So today, I will briefly talk about Koç Holding and Koç System, and then I will be talking about our IPA project, which has been created with the Ministry of Energy and Natural Resources and supported by the World Bank, titled Questionnaire Management Information System. And in the final part, I will be talking about Koç System's energy sector solutions and projections and references. So to briefly talk about Koç Holding, it is the only Turkish company which is among the Fortune Global 500 list. And as of 2020, the consolidated revenue is 183.8 billion Turkish liras. It has more than 94,000 employees, and it has 7% share in the Turkish export, and it carries out exports to over 150 countries. And its total revenue is 33% of the revenue, the national revenue. And Koç System has over 1,500 employees, and it has over 1,400 active clients, more than 30 national and international business partners. And Koç System is also a company of many firsts. For example, in the area of software, the first R&D center in Turkey belongs to Koç System, and also the first security operations center, SOC, in Turkey belongs to Koç System. And it has 3 data centers with over 8,500 servers, and it has more than 250 managed services clients, more than 150 corporate cloud clients, and more than 60 SAP clients. So these are important indicators which tell us how big the operations of Koç System are. So I would like to provide you some information about our focus sectors: finance, public, energy, automotive, insurance, retail, manufacturing, and telecommunications. And when we look at our solutions in these areas, IoT, analytics, business solutions, digital publications, security, data center, cloud, network, sound, and workstations. And again, in these areas, we focus on infrastructure, hardware, software, licensing, consultancy, installation, management, and maintenance. So in this part, I would like to talk about the EU IPA program project we carried out with the Ministry of Energy and Natural Resources, supported by the World Bank. The goals of the project was to enhance the capacity of the of the Ministry of Energy and Natural Resources in terms of the IT infrastructure, and we also had a goal to create an application titled Questionnaire Management Information System to collect data. And also we had the goal to accurately collect data so it could be an input for the National Energy Balance chart. And the benefits are it enhances the technological infrastructure of the institution, and it creates a redundant topology for disaster recovery architectures. And the questionnaire management information system is currently gathering data from over 700 plants, and it has a dynamic structure. So what were the components in establishing the energy data center project? We have the hardware components, which are servers and storage systems, and we also provided video wall and end-user computer hardware, and we also offered end-user training about this hardware. And on the software development side, as I mentioned earlier, we created the questionnaire management information system. So as I mentioned at the beginning of the presentation, we are going to focus on the software development side of the project, which is the questionnaire management information system. Now, we have an application that looks like a single application, but there are actually two applications running in the background. One is the admin application, admin software. So the business unit, the relevant business unit of the Ministry of Energy and Natural Resources uses the admin software. So it's all the administrative processes that are being run there. And then on the other software or the other application, we have the questionnaire participant side. So one of the most important, or few of the most important qualities of this questionnaire is the questionnaire template part. Now, as part of corporate life, many of us probably have faced the challenge of creating Excel files to collect data and then trying to consolidate that data, aggregate that data, and report that data. It's quite challenging. Now, with this system that we developed, we overcome many of these challenges. As you can see, there are various types of questions here, and we have key templates that we can create. And we are able to use different types of questions here, like multiple choice questions, single choice questions, open-ended questions, chart questions. So we can populate questions from different templates. And on the right-hand side, on the upper part here, you can see that basically we embedded an Excel file into the software. And at the end of the day, when the users respond to these questionnaires, this data is then recorded into the ministry's database. So in the related template part, we can or we have basically recorded all the data that we have that we want to acquire, and the questionnaires are then sent to the relevant parties. So it's ready, basically. And this is the questionnaire assignment part. So who do we send which questionnaire to? That's what we decide here. And you can set the name of the questionnaire, the beginning date, the ending date, and then you can send an email template if you're going to email the questionnaire. You can select the plant or wherever you want to send the questionnaire to. So all of these were designed together with the relevant business unit. And then afterwards, you can select the questionnaire participant list and you can assign the questionnaire, and the questionnaire is then delivered to the relevant parties. So once the questionnaires are sent, the Ministry of Energy and Natural Resources has the relevant business unit, which receives the responses, and it can view these questionnaires, can update them, can approve or decline them. So basically, all these questionnaires are generated on the screens of the relevant business unit professionals. And in addition to the digital qualities of the questionnaire management information system, it also has the quality to send printouts to the participants. As you can see here, there are various templates that can be managed here. So you can have updates on a previously written letter, and you can create letters in the same format to share them with the stakeholders. And when we look at the other part of the software, as I mentioned, the second part of the software, we see the questionnaire participant application. So whoever your relevant party is that you send the questionnaire to, all their data can be updated here: name, last name, email address, phone number, title. All of this data can be updated by the participants, and in this way, the data is always kept up to date. And the questionnaire participant application questionnaire screen is what you can see here. And you can see various questionnaires sent on various dates. Some of them have been answered, some are still pending for answers. So the questionnaires can be viewed here, or the participants can start to answer the questionnaires on the screen. And on the response part of the questionnaires, the questionnaires are answered. And as you can recall, on the template part, I showed you that there can be various types of questions generated. So those questions are answered on this part of the application. And the system also has report features, and all the responses given to multiple choice, single choice, or open-ended questions can be part of these reports. And you can set the type of graph that you would like to use, and you can see reports accordingly. And then the balance reports. Now, the balance reports are basically created authentically, tailor-made for the relevant business unit of the Ministry of Energy and Natural Resources, and it is used to create the national energy balance charts. So on each cell, all the data is recorded. And then when you click on the cell, when you right-click on the cell, you can create calculations. So basically, all the parameters in the questionnaires are entered into this calculation. And once you hit the button Run, the report is run and it is then created. So I would like to show you an example of the balance report. For example, for the year 2019, we can see the national energy balance chart here. So all types of calculations, from the share of hard coal to the share of lignite in national energy. You can see all the data here, and this is part of the Director General of Energy of the Ministry as well. And in terms of reporting capabilities, the questionnaire data report is very comprehensive. And on this screen, you can see a pivot chart and, for example, the amount of electricity that is provided and how it is utilized based on each sector can be seen here. All these amounts can be seen. And this report can also be exported into Excel. And our two final features that I'd like to talk about are the Turkey map report and the Sankey report. Now, on the Turkish map or Turkey map report, you can see the results based on the districts or the provinces of the facilities of the plants. And the provinces are colored based on the volume of data that is created on that province. and you can select the data that you like. For example, you can select parameter, and you can select electricity, for example, and then you can see the amount of electricity utilized based on each province. And in this part, we are going to hear about the energy sector solutions and the future projections of Koç system and Koç Digital. Now, Koç Digital is a new initiative created by Koç System recently, and we are working together with BCG, Boston Consulting Group. We are utilizing their know-how and experience. So we are focusing on analytics, Internet of Things, and we also have the Koç Digital Academy. So we have various subject areas in which we provide solutions. Now, as you know, data is like the oil of our age. And we are trying to reach information from data, and from information, we are trying to facilitate decision-making processes. So institutions have three main problems in terms of data governance. For example, not being able to clearly understand the value of the data. And in that sense, we are using benchmark solutions for our customers to be able to create or get the most out of the data they have. And in terms of know-how and experience deficiencies, we have a lot of competencies. So we provide data analysis, data architecture, data engineering, and data science support to our clients. And then we have business-focused and IT-focused investments. And we support our clients in terms of eliminating the risks based on IT needs. So for just like it is for many other sectors, for the energy sector as well, we believe that Internet of Things is going to be very important. Now, in this area, we have our authentic platform. It's called Platform 360, and we have a service layer here that allows the IoT to function. Now, as you know, Koç Holding has a great industrial infrastructure from automotive to energy. They have a lot of initiatives, and we have 1.8 million sensors that we process through this platform, and we acquire information from the data, and we are able to run programs, do data aggregation and storage, and manage connection. And we focus on Industry 4.0 consultancy, manufacturing information systems, installation management, manufacturing traceability, manufacturing functioning systems, and asset and energy monitoring remotely. So on the smart infrastructure side, we have SiteLink. On the smart energy side, we have Systemetrics. And for smart manufacturing, we have Manumetrics as our programs. And Platform 360 also was granted various awards in three different categories. Our Platform 360 received 3 Stevie Awards. And in terms of IoT and analytical products, we focus on manufacturing information systems and predictive maintenance, industrial automation, and video analytics for occupational health and safety. In terms of advanced analytics, what we do is advanced analytical implementations focus on the big data architecture. And what we focus on is HR analytics, video analytics supported occupational health and safety, mining analytics, workforce optimization, demand forecast, stock optimization, and data governance models. And again, in the Stevie Awards in 2019, we received the HR Analytics Award. And for 2019 IGC, we got the Optimization Project Award. With advanced analytics, we are able to address some very specific problems. For example, we had a project for a refinery. We focused on machine learning for crude oil. Now, the mix of crude oil is very important for distillation processes, and you need to receive high margin values from crude oil. So the company wanted to focus on this area, and we focused on the data collection, and we set key parameters, and we created a prediction model. And our prediction model's accuracy was at 80% for critical mixtures, and this refinery had a lot of cost saving through this implementation. Now, in terms of energy saving, another future technology is blockchain, especially in terms of electricity generation and distribution. We believe blockchain is going to be very important. Now, there is a new trend for the future. For example, individual consumers, household consumers basically, were only consumers. However, now they can install a solar panel on their roof or install a wind turbine, and they can turn into an energy generation facility through this. So they've taken the word consumer and combined it with producer, and there is the new term prosumer for this concept. So basically, the customer identity is going through a transformation. So prosumers can generate their own energy, and they can store or sell the energy that they're not using, and they can do that through blockchain. Now, what is blockchain? Well, it is a system, a data registration system, which is distributed. So it's like a ledger. And with smart meters, blockchain that support blockchain, you can create smart contracts and you can have energy exchanges through this system. Now, in terms of blockchain-based grids, we have a pilot project or example project together with ENTEC. And it's a project with ENTEC and Koç system. We installed the solar energy power plants on the security building roofs of the Çamlıca Business Center blocks. And we also have EV charging and carports installed in the parking lot part using the blockchain infrastructure. And ENTEC is basically going to be focusing on the panel installation and the installation of other systems. And Koç system will be focusing on the blockchain technology software. So we have 122 kilowatts of installed capacity, a carport for 4 vehicles, 10 kilowatt hours capacity of battery, and the blockchain software here. Now, blockchain is also very important on the supply chain side. Now, in this part, there is a demand coming from the client, and then a smart contract is created, then there's an approval, and a order is created, and then the supplier approves this order. And once the approvals are completed, then the product is delivered and the invoicing is done. So we believe blockchain is going to be very important for smart contracts as well. And in terms of supply chain traceability, for example, is a challenge, but blockchain has the inspection capabilities. And then there are some compliance challenges faced in supply chain. And the constancy future of blockchain is going to be a solution for that. And then in terms of flexibility, the challenges faced will be resolved with smart contracts through blockchain. And for stakeholder management, blockchain being an unmediated environment and being able to store distributed data is going to be a solution. Now, in terms of our other energy sector solutions, digital mining is also part of our solutions. So BCG and thus Koç Digital have great know-how, exploration and construction, predictive maintenance or bottleneck analysis. In all these areas, we can detect the problems and we can provide all types of software, hardware, sensor data, or IoT solutions. And in Turkey as well, we have some projects that we are carrying out. To give an example, for example, we can take the canvas data of a truck and we can decide what the optimum gear would be for that truck when it's going uphill. And we can receive some vibration data to understand its inclination towards any maintenance issues. So with all these activities, we are able to ensure that the operations carry on without interruption. And this creates great savings for the sector. Now, of course, we are able to process a variety of sensors through our platform 360. For example, GPS, heat, vibration sensors. We can use all of these, which can be suitable for that mining area. And we can then make sure the data collected from these sensors are delivered timely to the client. And other energy sector solutions we have is also the operational margins, so to increase the profits of refineries, and we have comprehensive solutions here as well. And again, we also have smart grid solutions for the energy sector. We have smart grid projects. We have a project at an electricity distribution institution. So we are able to track energy consumption online and remotely, and we can watch the changes in instant consumption, and we can prevent losses. So in the digital transformation of the energy sector, we are very happy to be by your side. And as Koç System, we are very happy to be sharing our know-how and experience in this area, and we will happily do so in the future as well. Thank you for listening to us. Goodbye.
We would like to thank Mr. Kaptanoğlu for his presentation. We will now take a 15-minute break. After the break, we look forward to seeing you again.
Enerji, insanların yaşamlarını sürdürebilmeleri için gerekli bir kaynak, ülkelerin refahını sağlamak için de en önemli araçlardan biridir. Artan dünya nüfusuyla gittikçe tükenen hidrokarbon kökenli enerji kaynaklarının yanında, yeni ve yenilenebilir enerji kaynaklarının kullanımını arttırmalıyız. Bu doğrultuda Avrupa Birliği, iklim değişikliğiyle mücadele amacıyla enerji verimliliğinin ve yenilenebilir enerji kaynaklarının payının arttırılmasını hedefliyor. Biz de bu hedef doğrultusunda ülkemizin artan enerji ihtiyacını karşılayarak enerji arz güvenliğini sağlamaya, enerji alanında ülkemizin rekabet edebilirliğini artırmaya ve sürdürülebilir kalkınma temelinde çevrenin korunmasına katkı sağlamaya çalışıyoruz. 2007 yılından bu yana enerji sektöründe kapasitenin geliştirilmesi için Avrupa Birliği finansmanıyla toplamda 106 milyon avro tutarında proje yürüttük ve yürütmeye devam etmekteyiz. Elektrik alanında uygulanan projelerle ülkemizin elektrik sistemi, Avrupa'nın elektrik sistemiyle uyumlu hale getirildi ve elektrik piyasamız geliştirildi. Bilinçli enerji tüketiminin sağlanabilmesi için enerji verimliliği projeleriyle binalarda enerji kimlik belgesi uygulamasına geçildi ve enerji tüketen ürünlerin enerji tüketimlerine dair bilgilendirmeler ürün ambalajlarında yer almaya başladı. Enerji verimliliği ve yenilenebilir enerji alanında Türkiye'nin uygulamaya koyacağı eylem planlarının hazırlıkları da yine Avrupa Birliği finansmanıyla yapılan projeler kapsamında tamamlandı. Daha iyi bir dünya ve ortak geleceğimiz için doğaya daha az zararı olan yenilenebilir enerji kaynaklarından faydalanmak amacıyla Avrupa Birliği ile çalışmalarımıza devam edeceğiz.
Değerli sektör paydaşlarımız, Bilindiği üzere aday ülke olarak Avrupa Birliği tarafından sağlanan katılım öncesi mali yardım fonlarından istifade ediyoruz. Enerji ve Tabii Kaynaklar Bakanlığı olarak ülkemize tahsis edilen İPA fonları ile enerji sektöründe kapasite geliştirme çalışmalarını gerçekleştiriyoruz. Bu kapsamda İPA fonları ile 2007 yılından bu yana enerji sektöründe toplamda yaklaşık 106 milyon avro tutarında teknik yardım ve pilot ekipman alımı projelerini yürütmekteyiz. İPA 1 ve 2 dönemlerinde bakanlığımızın ilgili kuruluşları, belediyeler ve üniversitelere yenilenebilir enerji ile enerji verimliliği kapasite geliştirme alanlarında destek sağlarken yine belediyelerimize pilot uygulamalarla yenilenebilir enerji sistemleri, verimli su pompaları ve elektrikli otobüs temini noktasında yardımcı olmaktayız. Ayrıca elektrik ve doğalgaz üretim ve iletiminde verimlilik, deniz üstü rüzgar alanında saha geliştirme ve ölçüm çalışmaları, enerji talebi ve enerji verimliliği modelleme kapasitesinin güçlendirilmesi gibi birçok farklı alt sektörde teknik yardım ve pilot ekipman alımı projelerini yürüttük ve yürütmeye devam etmekteyiz. Önümüzdeki süreçte İPA 3 dönemi kapsamında da enerji sektöründe dönüştürücü bir etkinin sağlanması için kamu, özel ve sivil toplum sektörlerini birlikte ilgilendiren teknolojilerinin yerleştirilmesine, inovasyonun önceliklendirilmesine, sürdürülebilir, verimli, akıllı altyapıların kurulmasına, dijitalleşmenin hızlandırılmasına yönelik projeleri de hayata geçirmek için çalışmalarımızı sürdürüyoruz. Ortak geleceğimizi Avrupa Birliği ile ortak yürüttüğümüz yüzlerce proje ile şekillendiriyor, değerlerimizi yarına taşıyoruz.
Aklımda.
Enerji verimli buzdolabı almak yetmez. Onu verimli kullanmak da aklımda.
Kumandayı verir misin hayatım? Aklımda. Klimayı ideal oranda çalıştırıp enerjiyi boşa harcamamak da aklımda. Çak.
Hayatım, ben markete gidiyorum.
Hayatım.
Aklımda. Yakın yerlere arabayla gitmemek de aklımda. Hem senin geleceğin için, hem aile bütçemiz için, hem de kendi sağlığım için. Enerjimizi verimli kullanmak her zaman aklımda. Enerji verimliliğini aklından çıkartma, aklınla verimli yaşa.
Başladı.
Hadi anneciğim.
Amcanlar ısınma giderlerini yarıya indirmek için ne yaptı?
Yalıtım.
Ne oldu diyordu yani?
Mucize.
Evlenirken beyaz eşya aldınız. Ne sınıfıydı?
Bol artılı. Az elektrik harcıyor.
Evet.
Ne demek yani bu?
Akıllılık.
Ahmet, bazen toplu taşıma kullanıyorsun.
Evet.
Kısa mesafe yürüyorsun
Tamam.
ya. Neden?
Doğa için.
Araba az yaksın diye 2500 devirde kullanıyorsun. Camı klimayı aynı anda açmıyorsun ya. Bu nasıl kullanım oluyor?
Verimli.
Ne verimliliği? 3, 2.
Enerji verimliliği.
Enerji verimliliği tabii.
Aynı kapasitedeki ürünlerden verimli olanı tercih et, aklınla verimli yaşa.
Enerji, insanların yaşamlarını sürdürebilmeleri için gerekli bir kaynak, ülkelerin refahını sağlamak için de en önemli araçlardan biridir. Artan dünya nüfusuyla gittikçe tükenen hidrokarbon kökenli enerji kaynaklarının yanında, yeni ve yenilenebilir enerji kaynaklarının kullanımını arttırmalıyız. Bu doğrultuda Avrupa Birliği, iklim değişikliğiyle mücadele amacıyla enerji verimliliğinin ve yenilenebilir enerji kaynaklarının payının arttırılmasını hedefliyor. Biz de bu hedef doğrultusunda ülkemizin artan enerji ihtiyacını karşılayarak enerji arz güvenliğini sağlamaya, enerji alanında ülkemizin rekabet edebilirliğini artırmaya ve sürdürülebilir kalkınma temelinde çevrenin korunmasına katkı sağlamaya çalışıyoruz. 2007 yılından bu yana enerji sektöründe kapasitenin geliştirilmesi için Avrupa Birliği finansmanıyla toplamda 106 milyon avro tutarında proje yürüttük ve yürütmeye devam etmekteyiz. Elektrik alanında uygulanan projelerle ülkemizin elektrik sistemi, Avrupa'nın elektrik sistemiyle uyumlu hale getirildi ve elektrik piyasamız geliştirildi. Bilinçli enerji tüketiminin sağlanabilmesi için enerji verimliliği projeleriyle binalarda enerji kimlik belgesi uygulamasına geçildi ve enerji tüketen ürünlerin enerji tüketimlerine dair bilgilendirmeler ürün ambalajlarında yer almaya başladı. Enerji verimliliği ve yenilenebilir enerji alanında Türkiye'nin uygulamaya koyacağı eylem planlarının hazırlıkları da yine Avrupa Birliği finansmanıyla yapılan projeler kapsamında tamamlandı. Daha iyi bir dünya ve ortak geleceğimiz için doğaya daha az zararı olan yenilenebilir enerji kaynaklarından faydalanmak amacıyla Avrupa Birliği ile çalışmalarımıza devam edeceğiz.
Değerli sektör paydaşlarımız, bilindiği üzere aday ülke olarak Avrupa Birliği tarafından sağlanan katılım öncesi mali yardım fonlarından istifade ediyoruz. Enerji ve Tabii Kaynaklar Bakanlığı olarak ülkemize tahsis edilen İPA fonları ile enerji sektöründe kapasite geliştirme çalışmalarını gerçekleştiriyoruz. Bu kapsamda İPA fonları ile 2007 yılından bu yana enerji sektöründe toplamda yaklaşık 106 milyon avro tutarında teknik yardım ve pilot ekipman alımı projelerini yürütmekteyiz. İPA 1 ve 2 dönemlerinde bakanlığımızın ilgili kuruluşları, belediyeler ve üniversitelere yenilenebilir enerji ile enerji verimliliği kapasite geliştirme alanlarında destek sağlarken yine belediyelerimize pilot uygulamalarla yenilenebilir enerji sistemleri, verimli su pompaları ve elektrikli otobüs temini noktasında yardımcı olmaktayız. Ayrıca elektrik ve doğalgaz üretim ve iletiminde verimlilik, deniz üstü rüzgar alanında saha geliştirme ve ölçüm çalışmaları, enerji talebi ve enerji verimliliği modelleme kapasitesinin güçlendirilmesi gibi birçok farklı alt sektörde teknik yardım ve pilot ekipman alımı projelerini yürüttük ve yürütmeye devam etmekteyiz. Önümüzdeki süreçte İPA 3 dönemi kapsamında da enerji sektöründe dönüştürücü bir etkinin sağlanması için kamu, özel ve sivil toplum sektörlerini birlikte ilgilendiren teknolojilerinin yerleştirilmesine, inovasyonun önceliklendirilmesine, sürdürülebilir, verimli, akıllı altyapıların kurulmasına, dijitalleşmenin hızlandırılmasına yönelik projeleri de hayata geçirmek için çalışmalarımızı sürdürüyoruz. Ortak geleceğimizi Avrupa Birliği ile ortak yürüttüğümüz yüzlerce proje ile şekillendiriyor, değerlerimizi yarına taşıyoruz.
Aklımda.
Enerji verimli buzdolabı almak yetmez. Onu verimli kullanmak da aklımda.
Kumandayı verir misin hayatım? Aklımda. Klimayı ideal oranda çalıştırıp enerjiyi boşa harcamamak da aklımda. Çak.
Hayatım, ben markete gidiyorum.
Hayatım.
Aklımda. Yakın yerlere arabayla gitmemek de aklımda. Hem senin geleceğin için, hem aile bütçemiz için, hem de kendi sağlığım için. Enerjimizi verimli kullanmak her zaman aklımda. Enerji verimliliğini aklından çıkartma, aklınla verimli yaşa.
Başladı.
Hadi anneciğim.
Amcamlar ısınma giderlerini yarıya indirmek için ne yaptı?
Yalıtım.
Ne oldu diyordu yani?
Mucize.
Evlenirken beyaz eşya aldınız. Ne sınıfıydı?
Bol artılı. Az elektrik harcıyor.
Evet.
Ne demek yani bu?
Akıllılık.
Ahmet, bazen toplu taşıma kullanıyorsun.
Evet.
Kısa mesafe yürüyorsun
Tamam.
ya. Neden?
Doğa için.
Araba az yaksın diye 2500 devirde kullanıyorsun. Camı klimayı aynı anda açmıyorsun ya. Bu nasıl kullanım oluyor?
Verimli.
Ne verimliliği? 3, 2.
Enerji verimliliği.
Enerji verimliliği tabii.
Aynı kapasitedeki ürünlerden verimli olanı tercih et, aklınla verimli yaşa.
Enerji, insanların yaşamlarını sürdürebilmeleri için gerekli bir kaynak, ülkelerin refahını sağlamak için de en önemli araçlardan biridir. Artan dünya nüfusuyla gittikçe tükenen hidrokarbon kökenli enerji kaynaklarının yanında, yeni ve yenilenebilir enerji kaynaklarının kullanımını arttırmalıyız. Bu doğrultuda Avrupa Birliği, iklim değişikliğiyle mücadele amacıyla enerji verimliliğinin ve yenilenebilir enerji kaynaklarının payının arttırılmasını hedefliyor. Biz de bu hedef doğrultusunda ülkemizin artan enerji ihtiyacını karşılayarak enerji arz güvenliğini sağlamaya, enerji alanında ülkemizin rekabet edebilirliğini artırmaya ve sürdürülebilir kalkınma temelinde çevrenin korunmasına katkı sağlamaya çalışıyoruz. 2007 yılından bu yana enerji sektöründe kapasitenin geliştirilmesi için Avrupa Birliği finansmanıyla toplamda 106 milyon avro tutarında proje yürüttük ve yürütmeye devam etmekteyiz. Elektrik alanında uygulanan projelerle ülkemizin elektrik sistemi, Avrupa'nın elektrik sistemiyle uyumlu hale getirildi ve elektrik piyasamız geliştirildi. Bilinçli enerji tüketiminin sağlanabilmesi için enerji verimliliği projeleriyle binalarda enerji kimlik belgesi uygulamasına geçildi ve enerji tüketen ürünlerin enerji tüketimlerine dair bilgilendirmeler ürün ambalajlarında yer almaya başladı. Enerji verimliliği ve yenilenebilir enerji alanında Türkiye'nin uygulamaya koyacağı eylem planlarının hazırlıkları da yine Avrupa Birliği finansmanıyla yapılan projeler kapsamında tamamlandı. Daha iyi bir dünya ve ortak geleceğimiz için doğaya daha az zararı olan yenilenebilir enerji kaynaklarından faydalanmak amacıyla Avrupa Birliği ile çalışmalarımıza devam edeceğiz.
Değerli sektör paydaşlarımız, bilindiği üzere aday ülke olarak Avrupa Birliği tarafından sağlanan katılım öncesi mali yardım fonlarından istifade ediyoruz. Enerji ve Tabii Kaynaklar Bakanlığı olarak ülkemize tahsis edilen İPA fonları ile enerji sektöründe kapasite geliştirme çalışmalarını gerçekleştiriyoruz. Bu kapsamda İPA fonları ile 2007 yılından bu yana enerji sektöründe toplamda yaklaşık 106 milyon avro tutarında teknik yardım ve pilot ekipman alımı projelerini yürütmekteyiz. İPA 1 ve 2 dönemlerinde bakanlığımızın ilgili kuruluşları, belediyeler ve üniversitelere yenilenebilir enerji ile enerji verimliliği kapasite geliştirme alanlarında destek sağlarken yine belediyelerimize pilot uygulamalarla yenilenebilir enerji sistemleri, verimli su pompaları ve elektrikli otobüs temini noktasında yardımcı olmaktayız. Ayrıca elektrik ve doğalgaz üretim ve iletiminde verimlilik, deniz üstü rüzgar alanında saha geliştirme ve ölçüm çalışmaları, enerji talebi ve enerji verimliliği modelleme kapasitesinin güçlendirilmesi gibi birçok farklı alt sektörde teknik yardım ve pilot ekipman alımı projelerini yürüttük ve yürütmeye devam etmekteyiz. Önümüzdeki süreçte İPA 3 dönemi kapsamında da enerji sektöründe dönüştürücü bir etkinin sağlanması için kamu, özel ve sivil toplum sektörlerini birlikte ilgilendiren teknolojilerinin yerleştirilmesine, inovasyonun önceliklendirilmesine, sürdürülebilir, verimli, akıllı altyapıların kurulmasına, dijitalleşmenin hızlandırılmasına yönelik projeleri de hayata geçirmek için çalışmalarımızı sürdürüyoruz. Ortak geleceğimizi Avrupa Birliği ile ortak yürüttüğümüz yüzlerce proje ile şekillendiriyor, değerlerimizi yarına taşıyoruz.
Aklımda.
Enerji verimli buzdolabı almak yetmez. Onu verimli kullanmak da aklımda.
Kumandayı verir misin hayatım? Aklımda. Klimayı ideal oranda çalıştırıp enerjiyi boşa harcamamak da aklımda. Çak.
Hayatım, ben markete gidiyorum.
Hayatım.
Aklımda. Yakın yerlere arabayla gitmemek de aklımda. Hem senin geleceğin için, hem aile bütçemiz için, hem de kendi sağlığım için. Enerjimizi verimli kullanmak her zaman aklımda. Enerji verimliliğini aklından çıkartma, aklınla verimli yaşa.
Başladı.
Amcanlar ısınma giderlerini yarıya indirmek için ne yaptı?
Yalıtım.
Ne oldu diyordu yani?
Mucize.
Evlenirken beyaz eşya aldınız. Ne sınıfıydı?
Bol artılı. Az elektrik harcıyor.
Evet.
Ne demek yani bu?
Akıllılık.
Ahmet, bazen toplu taşıma kullanıyorsun.
Evet.
Kısa mesafe yürüyorsun
Tamam.
ya. Neden?
Doğa için.
Araba az yaksın diye 2500 devirde kullanıyorsun. Camı klimayı aynı anda açmıyorsun ya. Bu nasıl kullanım oluyor?
Verimli.
Ne verimliliği? 3, 2.
Enerji verimliliği.
Enerji verimliliği tabii.
Aynı kapasitedeki ürünlerden verimli olanı tercih et, aklınla verimli yaşa.
Distinguished participants, welcome back. We will continue our program with the presentation of Mr. Benan Başoğlu, Head of the Energy Efficiency Department in EUH, Electricity Generation Company, titled Data Collection and Management in Hydroelectric Power Plants. The floor is yours. Hello, everyone. My name is Benan Başoğlu. I am the head of the Energy Efficiency Department at EUH, the Electricity Generation Company. Well, although the name of our department is Energy Efficiency, this should not mislead you because under our department, although we have units working in the field of energy efficiency, we mainly focus on collection of industrial data, processing of data, visualization of data, reporting of data, and most recently, we have directorates working on the development of automation systems. So we have dedicated teams for those issues. So we mainly function as an engineering unit, so to speak. So today in my presentation, I will be talking about our activities in the last decade within EUH in the field of digitalization and digital technologies. I will be providing some information in that regard. Of course, within EUH, apart from our department, we have many other departments, and those departments also fulfill duties regarding their own fields, and they're also involved in digitalization activities. And our activities mainly focus on data regarding automation and monitoring of industrial data from power plants. And of course, we have some joint activities together with other departments. So the activities of EUH for digitalization are going to be are more than what I'm going to present you today. We have more activities, of course. So first, I will start with an introduction on digitalization. I will give you the basic definitions. And then I will talk about why digitalization is important for our sector, for the energy sector. Then I will talk about one of the most important issues for digitalization, which is data. I'll talk about why data matters, why it is important, because at the end of the day, data lies at the heart of digitalization. Then I will talk about the activities, the equipment or hardware development activities within EUH. And I'll talk about our current projects as well as our plans for the future. So, to start with, let's talk about digitalization. Digitalization is now a reality of our time, especially as a result of the rapid developments in the fields of IT technologies. We have a rapid transformation in the field of digitalization. All the data we could store and process on paper previously are now digitized, and they can be used for many different purposes to create benefit for our companies. Thanks to the development of these technologies, these are now available. So there is now an unprecedented pace in terms of these digital technologies becoming a part of our lives, especially during the pandemic. The importance of all this digital data is ever increasing. So digitalization and the impact of digitalization can be seen at many different levels. We feel it, for instance, at personal level. Most recently, I charged my cell phone, but it wasn't charging. And I was panicked. I didn't know what to do. All my personal information, all the information of my contacts, my notes, everything was stored on my mobile phone, my cell phone. I didn't know what to do. So this is the extent to which we are dependent on digital technologies. Then, at company level, digitalization is important. The companies are also in this process. And then we have social level, country level, and global level. So at all levels, we see the impact of digitalization, and we are continuing to live the impact and effects of digitalization. Nowadays, no company, country, or society can neglect the developments in the field of digital technologies. No one can turn their backs on this process of digitalization. It's not possible anymore. If people do so, if they neglect these technologies, then they will no longer be able to survive. So digital technologies are directly impacting the competitiveness of entities. So we need to take our place actively in this race. That would be the smartest step to take in this race. So companies, thanks to these technologies nowadays, are able to increase the quality of their products and services. So if we neglect, if we turn a blind eye on these technologies, we will no longer be able to develop ourselves in terms of the quality of our products and services. Now, we also have process automation. If we do not take the necessary steps in that regard, we will have to use our workforce in a different way. And then communication is also impacted. So if we turn our backs on this, we will not be able to seize this opportunity to get faster results in terms of communication in business life. So the innovation brought by digitalization is not limited to these things that I have listed. Actually, in many fields of the business world, we are seeing the impact. It's changing our processes, it's enriching our work fields. We now are expecting different skills and competences from the employees. The way we store, collect, and manage data is changing. And these new technologies are even having an impact on us in terms of how we choose our executives and managers. Now, leadership skills are taken into consideration. Again, company cultures, corporate cultures are changing. Time management is changing. Now, time management is done in an easier way. Again, social media, big data, geographical information systems, Internet of Things, virtual reality, all these things are brought to our lives thanks to digitalization. On the other hand, we are working in a very critical sector, namely energy. We know that energy is a very important commodity for the societies. I don't even need to mention the importance of energy. Even the shortest outages are not tolerated anymore. So it's a top level need. And the development levels and welfare levels of countries are increasing. So only through effective management we can have a reliable access to the energy resources. And of course, we need to also have effective decision-making mechanisms. Sometimes decision-making processes can be easy, but most of these processes are complex and difficult because the decisions we are going to take will impact people in a different way. They might be impacting one group of people in one way and one group of people in a different way. One group might be appreciating your decision and the other group might be reacting to your decision. And the decisions we're going to take might even impact the next generations in a positive or negative way. Of course, this complexity and these challenges also bring along a need to use the data effectively to make the right decisions. So, with this rapid change, we have this complexity in the energy sector now, which also makes decision-making processes more complex. So, we have the liberalization of the markets, deregulation processes, and shifting to a free market from the centralized approach. And these are elements that are making decision-making processes more difficult. So, as a result, we have to say that we now have digitalization, which is inevitable, and we have many different challenges along this way. On this slide, I'm trying to summarize this pathway to digitalization. It starts with a preliminary preparation, then continues with the development of support systems for decision making, and then ends with continuous improvement. So, most important items are related to preliminary preparation. Most important thing for digitalization is data. Of course, Data helps us to develop our products and services through digitalization. And apart from data, we have also infrastructure, which is also very important. Yes, we have the data, but of course, how are we going to collect this data, for instance, especially in industrial plants, in complex plants? And when it comes to these plants, we have thousands and thousands of data. So it's very important to have the infrastructure. When we talk about power plants, we have thousands of pieces of data. So all this data can have different use cases for different purposes. And of course, we also need the necessary human resources for this digitalization journey. We need the people with the right qualifications and skills. Because of digitalization, we are now looking for different skills and competences in our employees. And this decision support systems also require effective applications. And it's also about effective use of resources through optimization activities. So we can say that at the heart of digitalization lies the decision support systems. And the decision support systems are composed of four main components. We have a lot of data that we collect, and if we're talking about an industrial environment, we are creating big data. So we have to somehow manage this big data. And we can do it thanks to this model. We need a data management component to manage the data, and then we need to be able to process the data collected to convert it into information. We need to have the models to be able to do this, and we need to have a component for these models. And we also need a component for information management. And the information generated needs to be transferred to the relevant people at relevant layers of the company. So we need a user interface. So this decision support system, or these systems, identify the relation between different data and turn the data into meaningful information, and then after this information, it comes up with knowledge that can help us take the relevant decisions. So, of course, we have many different systems to be able to have conscious and effective decision making. In our department, we also have the ISO 5001 energy management system. We are working on this system. We are having baseline studies, and to operate this system, of course, the data that we will be collecting from the facilities regarding energy use is very important. So this holds true for all management systems, not only for energy management systems, but for all management systems. So converting data into information thanks to decision support systems is very important. And the best example for this is from Europe. One of the biggest energy companies in Europe and in the world is EDF. It's the energy generation, public energy generation company of France. And in this current panel, we also have another speaker from EDF, and they collect data from their plants, and they have about 1,200 units, and they create a very big data pool, and thanks to their decision support systems, they are able to use the data from this data pool for different purposes. They have different use cases. And as you can see on this table, you have level 1, where you have the operators work on the collected data around the clock, and they use the data for continuous monitoring, and they can intervene on a real-time basis. At level 2, we have special teams, dedicated teams that analyze the weekly or monthly trends. It's about trend monitoring, and they try to avoid the problems before they occur. At level 2, they have an experts network. So on demand or as required, they use the data for support and expertise, diagnosis and prognosis. So the EDF has developed a platform called Lemon, and under this platform, they have about 300 software developed for engineering, analysis, diagnosis, and prognosis. Again, thanks to the system, EDF can work around their system. 1,200 units are monitored from 5 different centers, and the critically important 100 hydraulic power plants are controlled from 4 different centers. We're not only talking about France, but we're talking about other countries such as Spain. So they can have remote controlling or monitoring for all these facilities. And we should also be keeping up with these developments. We shouldn't be lagging behind all these developments. So the information in detail about EDF will be provided by our colleague from EDF. So now, let's talk about our activities at EUH regarding digitalization. I will give you the information about our activities briefly. In the last 10 years about digitalization, of course, we have been doing a lot of things as EUH. We have been receiving or collecting some data from the power plants in line with the requirements and needs of our department. We have a 3-layered system which we constantly improve, and we are using the system for different purposes. So first, we have the back layer that collects the information from the facilities. We have the middle layer where we have the data management. It's a database. And then we have a front layer which visualizes the data for our employees, and is composed of interfaces. In the front layer, we're doing very well. We have developed these decision support systems internally, in-house. So we have a power plant monitoring system, R&D monitoring system. All these systems have been commissioned last year. They are developed totally in-house, internally. So these systems are our own systems, as we can say. And then again, we have developed some monitoring software that are available on iOS and Android. So we are developing many different solutions in that regard. So we have very strong and hardworking teams dedicated to these issues. And currently we have some ongoing activities for the energy efficiency web portal, which we are planning to commission this year. A lot of information about energy efficiency will be accessed through this portal. Again, this is totally developed in-house, internally. So this is about the front layer. What about the back layer where we collect the industrial information? Things are a little bit different here. So, as there is no standardization understanding, we have a lot of problems and challenges on that layer. We still have facilities based on analog systems. This is also another challenge. So it's very difficult to collect data from these facilities, if not impossible. And one of the most challenging topics for us is that the power plant suppliers are different entities. For each power plant, we have different industrial data collection and automation systems in place. You see the examples. In Bursa, we have Mitsubishi. In Afşin, we have Alstom. In Deriner, we have Andritz. In Istanbul, we have Siemens. So at different power plants, we have different systems running. Yes, maybe they have perfect technologies, all of them, but the data to be collected from all these separate systems and facilities need to be consolidated. When it comes to consolidation, it's really very difficult for us. It's very challenging for us. So, these important technologies turn into a garbage of technologies for us because they are different from one another, and they are really challenging us in terms of, for instance, training specialized human resources. An employee working in one power plant cannot work with the system in another power plant. In terms of spare parts, again, we are having difficulties, and then in terms of the use of different protocols for data transfer, it's very challenging. And cybersecurity is another challenge for us. So to be able to overcome all these challenges, about 2 years ago, the senior management, and with the support of the senior management and our general director, we started a project, so that a vision project, so that data collection and automation infrastructure for all these power plants will have a standardization. And with this project, we will have our standard data collection hardware and software that will be developed. On this slide, you see the already developed products. And here on this slide, you see the pictures of the completed products. So, conceptual design, preliminary design, basic design, detailed design, and manufacturing are different phases, and all these phases were used to develop these products. We have modules for data collection and automation that were successfully taken under projects, and development activities have reached a certain maturity. We have tested them in our power plants, and they are now further being developed. So these are the products that we have developed. Let me give you some examples. This is our communication module. This is our digital input with 16 channels. This is digital output with 16 channels. This is analog input with 4 channels. This is analog output with 4 channels. This is 50-watt power supply module. And on the communication card, we have a 25-volt module. The general specifications of the modules are that they can be used for bus line communication. So all our cards have 1,500 volts channel field insulation. They are developed in line with international standards. For each rack, we have 19-inch 3U structures. And for data transfer and automation, we have many different software developed. We have SCADA software, of course, which is very important for us. It's the standard for all the power plants and infrastructure. So we have our SCADA software so that we can create the control algorithms in the power plants. So we have a software for that. And also we have control software that can be used in an embedded way or on the pack. So we have different products that are being developed. So let's also talk about our ongoing projects. We have many different projects, such as the Energy Efficiency Web Portal project, which I already talked about. Then, for automation activities, we have this fast reacting CPU cards that are being developed. Currently, we are having the PCB drawings. Again, on Linux, we have the control software that will run on Linux. It's almost similar to real-time basis. And we have a pilot augmented reality application. And our engineering software and SCADA software are being further developed. We also have a new web reporting tool that we're trying to develop. And we also have a very simple vibration monitoring system. And we also are working on simulation systems. And on the other hand, we also have some planned projects for the future. We have PLC type cards, analog input and output cards will have 8 modules, and we also want to work on other projects. So this is all I wanted to present you today. I hope this information has been useful to you, and thank you so much for your patience. We would like to thank Mr. Benan Başoğlu for the valuable information he has shared. I would now like to leave the floor to Yves Laurent Beck, Program Manager at EDF, who will inform us about the best practices in data collection and management at hydroelectric power plants. The floor is yours.
Ladies and gentlemen, I am glad to present you the EDF monitoring and our return of experience of its industrial implementation at EDF Hydro. So what is the e-monitoring at EDF? It is an organization between different technical teams and operators within EDF, and internal means such as IT architecture and software solution for remote monitoring or power generation facilities. The objectives of our e-monitoring is to anticipate failing by detecting anomalous precursor in order to guarantee the safety and the performance of our fleet, in order to improve the availability rate and the lifetime of our equipment, to reduce the maintenance costs thanks to conditional-based maintenance and predictive maintenance recommendation, and to respect the contractual commitment towards the grids thanks to the ancillary services monitoring. Who are performing the monitoring at EDF? It's various internal dedicated monitoring centers independent of manufacturer. It represents more than 600 people at EDF in the 4 main fleets. At the beginning of the 2000s, we deployed at first the e-monitoring for our thermal fleet, and after that we deployed it for our hydro fleet, the nuclear fleet, and the renewable fleets. Today, our main assets, which represent more than 93 gigawatts, are remote monitored by the same organization and the same internal means. Our monitoring is organized based on 3 levels defined according to the reaction time and the depth of analysis. Level 1 is corresponding to supervision tool. It is a monitoring with a real-time reactivity carried out by the operators. It is often a monitoring of a single parameter and it's exceeding a simple threshold. Level 2 is a dedicated e-monitoring center which monitors machine behavior trends using multi-parameter monitoring software based on a machine learning algorithm. After a learning period, this tool takes into account operating history, the relationship between sensors and context of the use to predict the behavior of the asset. We are talking about early detection tool. Level 1 and level 2 are corresponding to a continuous monitoring. In case of doubt about the origin of the alarm and in case of need of advanced diagnosis, level 1 and level 2 operators can call on expert network called the level 3. At EDF Hydro, there are 7 expert networks specialized by material, such as for transformer, for the alternator, for the penstock, for the gates, or for vibration of the turbine and so on. It is important to mention that the efficiency of the collaborative network between each level is based on these are the same data that are used whatever the level of e-monitoring. The level 3 tools are advanced analysis software developed internally by EDF experts. The software are shared between the EDF's thermal fleet, nuclear fleet, and hydro fleet on a platform called Lemon. The EDF Hydro's expertise area covered by this software are vibration of rotating machinery, electrical generator diagnosis, transformer close monitoring and diagnosis, penstock monitoring, hydraulic performance, auxiliary services monitoring. This is not an anomaly detection software with an alarm level, but rather expert software for diagnosis and prognosis as shown in the screenshot on the right. You can see, for example, monitoring of auxiliary services graph, the Duval's triangle used for the dissolved gas analysis of transformer oil, the shaft displacement analysis, or the water pressure profile in a penstock. In addition to the response to the level 3 diagnosis on demand, the e-monitoring expert can provide a remote technical assistance for rebalancing, requalification, or startup assistance. Moreover, upstream of the scheduled main maintenance, our expert can provide, thanks to recorded data, an evaluation of the health status of the machine and help to define a suitable maintenance strategy. In 2011, EDF Hydro decided to deploy the e-monitoring of its main assets. We categorized our 1,200 hydraulic units through their issues and principally based on their power. While our EDF Hydro fleet was old, with a mean age of 60 years old, EDF Hydro's experts are provided a monitoring referential based on failure modes and or technical feedback occurred on our fleet. In total, we implemented around 8,400 new sensors on around 240 turbines. Although we have different technology and different suppliers of hydraulic turbines, we have defined standard instrumentation depending on the initial categorization. The added sensors are installed during the shutdown in order to limit the impact on the production of our hydro fleet. We can see here an example of sensor types for a Francis turbine. Our monitoring savings are calculating based on an auditable referential taking into account mainly a probability calculation of an estimation of avoid of loss of production, avoid of maintenance cost and reduction of engineering resources. As observed on the graph, gains are increasing well with our e-monitoring deployment. We observe that currently annual gains are stable and over than 13 million euros per year. our average return on investment is around 3 to 6 years, depending to the type of assets and monitoring models. Today, EDF propose to accompany other owners to deploy their e-monitoring with a prioritization on the highest profitability. Let me now to present you my first example. Before 2010, we had at EDF 1 to 2 penstock failure per year due to overpressure. Our experts have developed an e-monitoring system based on only one pressure sensor placed on the downstream two of the penstock. This sensor is connected to a disturbance recorder, which sends an alarm if a threshold is exceeded, and send the recorded data to Level 2 e-monitoring center. The Level 2 operators analyze the measurement thanks to a specific monitoring software. If the pressure value is considered problematic, the Level 3 sensor can call on the Level 3 expert who has modeling software that takes into account the mechanical properties of the penstock, its geometry, and recalculate for the pressure recorded the location of probable weakness along the penstock. Since 2010, after implemented this e-monitoring for more than 400 penstocks, we have not had any more penstock failure, and we hope this will continue. My second example is for transformer remote monitoring. It is important to mention that a transformer is a reliable equipment with a probability of less than 1% of damage per year per transformer. However, it's a strategic material for power generation. We qualified 3 grades of remote monitoring device and develop and are using a mobile device with a secure installation transformer on load for close monitoring of weak transformer. At date, we have 100 remote monitored transformer and plan to instrument 280 more during 3 next years. Moreover, thanks to our cockpit software, our experts are providing a mapping of the health index of our transformer fleet. Thanks to this information, the asset manager of each EDF fleet can target the maintenance efforts on equipment that need it. My last example concerns the vibratory monitoring of Hermillon hydropower plant in the Maurienne Valley in the French Alps. In the morning of the 23rd January, Level 2 e-monitoring center of EDF Hydro received an alert on an abnormal deviation of vibratory behavior of the Unit 2. At 2:00 p.m., Level 2 operator called experts for a Level 3 diagnosis. Experts then analyzed the recorded data, which confirm a rise of vibration and asymmetric evolution of displacement of the shaft. He is then remote connected to the on-site monitoring system in order to verify the measurement chain and if the machine's vibration level was still high. After an analysis of vibration signal with its expertise tool, he confirmed the abnormal behavior of the asset and diagnosed an imbalance probably due to a sudden loss or a sudden addition of material in the turbine. Although they recommended to stop the unit in order to inspect the turbine, the operator continued to produce due to the electricity request, but with a close remote monitoring of vibration thanks to our remote monitoring center. The next day, the unit is stopped and updated by the operator, who find 2 rock blocks at around 8 kilograms stuck in the blade of the turbine. The avoided cost of maintenance is estimated at around 80 €. I like to say that e-monitoring makes it possible to remove stones from our operator's shoes. Thank you very much for your attention.
As we thank Mr. Yves Laurent Beck for his presentation, we are moving on to the final session of the day. I would like to invite Advisor to the Minister of Energy and Natural Resources, Mr. Barış Sanlı, to share his valuable perspectives on digitalization in the energy sector. The floor is yours. Hello, this is Barış Sanlı. Today, I will be talking about the digitalization process and what is different this time, because the digitalization process started back in the 1960s or 80s, and I will talk about what's different now. Certain arguments, logical arguments. Yes, my presentation is going to be about what is next in digitalization, and these are my opinions, by the way, they don't belong to any institution. Well, the main question is, what is the vector direction of digitalization this time? Because the vector shows you the direction that you are moving towards. For instance, Industry 4.0 might be a point, but the vector shows you how and where this point will evolve, and that's the main question. I recently published an article whereby I asked 6 questions. What are the 6 questions that we are talking about? These are digital twins, digital post offices, beyond AI, virtualization, no consumer disturbance, in a sense that maybe the consumer doesn't even want to think about energy services. They want everything to move forward smoothly. So is it really possible to have no consumer disturbance? And last but not least, humanless energy services and full automation in all energy services. So, well, to make things clear, I would like to start with an analogy. For instance, if we have money, we all want to have a private chauffeur, right? A driver, but it comes with a cost. You'll have to pay a salary, you have to pay taxes, insurance, and you can't work the driver around the clock because of the employment law and legislation. And we now see an increasing number of driving jobs, people using their motorbikes, etc. But having a private chauffeur is a big cost item. So, what if we could rent a service like a taxi or Uber service? What if it was completely software-based and it was within reach in 5 minutes on demand? And even better, if it was an autonomous car. Imagine you order it, the car, autonomous cars with no driver, in the middle of the night, it can arrive, and you can have a deal with a company giving you a monthly price, just like a phone plan. So what we need to pay attention here is that once this is possible, and as this is a humanless system, it changes totally the business models. It explodes in a way the business models in a good way. Well, it creates, first of all, new business environments, like the plans, like you will pay 500 liras, 1,000 liras a month, or you can disaggregate the whole service. For instance, a driving service is about making a deal with a driver, paying a salary in exchange, but if you disaggregate the service, saying that I want family service, so that my kids will also be brought to school, or my spouse will be brought to work or shopping, so you can disaggregate the entire service. So at the same time, there will be many subcomponents of the same driving service. For instance, the driver might, if it's a human, the driver might say, I'm confused, am I your driver or am I, taking care of your errands? But if this is humanless, then you can create so many different services, such as urgent services. The car can come in 2 minutes, for instance, or vacation services, for instance, business services. For instance, in Istanbul, where there are business trips, they can provide fast services, and you can scale it all these services can be scaled and customized to all levels, because once you remove the human element out, you can copy it as much as you want. This might sound like a fantasy to you at the moment, but I don't know if you remember the initial times of telephone services. You would have an operator connecting you. You would have to call the operator and ask them to connect you urgently to a certain person. But now we no longer have this service. We have to deal with robots or bots most of the time. So the whole logic is that human is the most costly element of all the systems. Once you remove the human out of the system and replace them with software and algorithms, although it might sound like a bad idea or inhuman idea, this actually changes things. For example, energy audits. In Turkey, many buildings still do not have the ID documents. They want to get them issued, but they need to get a service for this. Somebody has to come, do the audit, inspection, take pictures, etc., etc. But what if this was totally based on software? What if you could get all the data from the satellite, for instance, virtual audits through drone thermal imaging, if all the information was uploaded to automated software, and then you could have the report of the audit immediately. Then, once you remove the human element, because the inspector, the auditor will not have to come to your building, take pictures, etc., etc., if you avoid all these things and use a software instead or an automated system, all of a sudden, you will be rapidly changing the business model. You can copy and do everything on real-time basis. And with 5 people only, you can do the job of maybe 3,000 people in Turkey. So that's the essence of the whole system. So reducing costs, increasing service volume, that's what we are seeing most recently. Like the cable services were there, and then you had streaming services. Cable TV, you would have to call them, get an appointment, somebody had to come to your house, install the cables, etc. But today, if you subscribe to Netflix or to a streaming service, you just need your credit card, you can subscribe immediately, and you can cancel your subscription anytime. So this new age, new era in digitalization is all about discussing these models. Maybe in 5 or 10 years we will see different new models. But we need to pay attention to something here. It's not only about chips or internet. It's more data. More data brings us more insight about people's lives, activities, etc. Imagine it this way. Energy is like a shadow of human activity. All energy consumption is related to human activity. You can include residential units and industry to this as well. So the more data you get or collect, the more insight you will have on human behavior and how people act. So more digitalization helps us to reveal the behaviors of people. People think digitalization is about ones and zeros, but the data that you can get is very interesting. For those who don't know, Cambridge Analytica, with a small code they wrote for Facebook, said that they manipulated the elections in US and UK. So that was revealed. That was a digital connecting platform. We're talking about Facebook, but there was so much data that after a while, by using that data, you can actually direct or guide people towards certain behaviors. So with this data becoming stronger, we can have behavioral models. We will see the behavioral models increase in number, and in many digitalization systems, we will take the human element out of the system more and turn it into a hardware, software, and then copy the software and see a multiplying effect. So this is called a gig economy. So people will be able to sell a surplus of their activities. I will give you a real case study from 2018. There is this company from US called Bijli. They published a document called What We Can Learn from Netflix. And I will also be showing you how Bijli is doing in 2021 at the end of my presentation. So imagine that we replace Netflix with an electricity company, because sometimes we think the consumer is different when they use electricity products, when they use Netflix, and it's a different consumer when they go to the supermarket. No, the consumer expectations are always same, even if they use different services. So the customer service people want from Netflix is also the same that they expect to receive from an electricity company. And of course, we have this group of people called Generation Z, and we need to really understand them. They want custom-made services designed personally for them. And here, we need to understand the feedback of the consumer better. That's why we use more behavioral AI methods. And most important of all these things is called hyper-personalization. So, how do we have this hyper-personalization? They say, for instance, Netflix has 2,000 different taste groups. Let's think about the energy sector in Turkey. We have residential units, commercial units, industrial units, low voltage, high voltage, many different units, right? Different services. So instead of these 5 services dictated to us by the regulation, if we get all the information about people from their payment information to consumer behavior, you can create different subscribers clusters. For instance, a group of subscribers who are extremely sensitive to costs, who are extremely sensitive to the environment, those who consume a lot of energy during the weekend, those who go to work during the weekdays. So Netflix has created 2,000 different groups, taste groups, to create specific services for them. So how can we apply this to the energy sector? In energy sector, we have what we call as bill shocks. So to avoid the bill shocks, these consumer groups, those consume that highly, but who don't have the affordability, we can send special messages to them to inform them about their existing or current consumption levels, and you can create services for them to avoid further consumption. So first rule is that you need to get to know your customer. How will you get to know your customer? With more data, with hyper-personalization and by clustering. The second thing is that by the way, after I read this document, I started to pay more attention to this, but we all know it, in fact. So we all have different preferences when it comes to our declared and revealed preferences. For instance, Adam Sandler's funny movies, imagine those movies. People watch them again and again, but they always rate them as 3 stars. Just like the Turkish actor Kemal Sunal movies, people keep using the movies, but they just give them 3 stars as rating. But people rate the documentaries that they can't even watch until the end as 5 stars. So after Netflix notices this, they change the rating system to thumbs up and thumbs down, and they actually increase their targets more, and they help the consumers to have more engagement with the system. So people's declared preferences are always different than their real or revealed preferences. So you can't understand the consumer by using more surveys or questionnaires. To understand the consumers, you need to take into consideration many different factors. When it comes to energy efficiency, we can give you the following option. You can provide the options, and then you can ask the consumer, I will do it or I will not do it. 2 options only, not many different answers, because the other data that you ask in the survey is already data you can get from the bills. Then design matters. So we no longer have 5 consumer groups imposed by the regulator. We maybe have 1,000 different groups in Turkey. So if you pay attention to what people pay attention to, then you can give them the right information. What Netflix did was the following. Those people who have watched romantic movies are shown artwork containing, again, romantic movies or Matt Damon or other actors, while someone who watches comedies might be shown artwork containing Robin Williams, for instance. So these are personalized messages. So if you have a consumer who is sensitive to environment, you can create a personalized message and send them the message by saying that by reducing your energy today, you'll help us plant 500 trees. And if it's a consumer who is sensitive to costs, you can send them a relevant message. Another thing is about engaging with the consumers. So instead of sending emails with the program name, if you send emails with the utility name, you have a more probability of the consumer reading that email. So when you design an engagement with the consumer, you need to pay attention to what matters to the consumer, and you need to give your message through that. So when we look at Bijli in 2021, we can say that under their customer experience, they have hyper-personalization, AI-powered smart alerts, digitalization. For call centers, they have remote audits, for instance, or a high bill analyzer. Furthermore, customer representative energy advisor. So once you turn things into a software, many things are possible. For energy efficiency, and then smart efficiency. They have, according to Bijli, they have behavioral energy efficiency and behavioral demand response. And they also have the smart shop. So after they check your behavior as a consumer, just like the App Store in Apple, they recommend a smart shop to you. By the way, these are all real models. Bijli is using these models, and they have many other solutions, just like the home energy management systems 2.0. You can design all these digital systems. Many of these things you can even do at home. But it's not only about data. It's the behavioral insight revealed by data. I have another example here. This article was highly debated. This was a subject in Nature. In a hotel in Switzerland, on the shower head, you see the picture of a polar bear and some ice melting under it. And the higher you consume the water, the higher or the more the ice cap melts. And this actually has reduced the water consumption of the consumers. So as one last case study, I would like to give you the example from the Texas energy crisis. Most recently, on the 15th of February, there was a cold wave in Texas, and it stopped the entire system. So natural gas production stopped, sensors were frozen, wind turbines were frozen, they didn't have heating systems, and as there wasn't enough generation, many sensors did not work. So all of a sudden, the electricity systems stopped, and there was a huge blackout. So under the digital services, there was a company providing services called Gridi. With a $10 monthly subscription, they would provide services to you. And with this model, by the way, we're going to have a period whereby we have more crises. So you need to always see to what extent these systems are crisis proven. So in 1 month, people received bills of $5,717 because their consumption went up. So, and Gridi went bankrupt because of this, for other reasons as well. And as they didn't warn the consumers that they would be paying these bills, so many people had problems, and then the Attorney General in Texas started a prosecution. But then what happened? Texas is one of the most developed electricity markets by the way, and as they had these problems, they commissioned power plants, and every time a plant was commissioned, the computer thought it was an additional capacity, so they decreased the prices. So the regulatory authority in that country takes a decision, and they say the price will be $9 $9,000 because they say the computer cannot compute correctly. There is a crisis in the system. So the price was declared as $9,000 megawatts per hour, whereby the same price was only $30 in Europe. So they couldn't warn the consumers, so the devices couldn't respond, home appliances, but people at the end had to face a major crisis. So there is a professor called Michael Weber in Texas. He also is staying in Paris. And as one of the persons who designed energy transformation, he was talking about his own experience. He had super efficient windows, insulation, electric heat pumps, natural gas backup, and large solar arrays in his house, but only the pump worked because the remote system couldn't work because they couldn't activate the system remotely because there was no electricity. They couldn't make use of the solar panels, or they couldn't use the electric heat pumps. So they had to face with this crisis. And the biggest lesson that Michael draws from this is that he says, I actually had to have a battery system in place. So I teach at Bilkent University, and there is a code, by the way, at the bottom of your screen. You can see it. You can all use it. Both Apple and Google are sharing mobility data during COVID. So you can merge the mobility data with electricity data from EPH, and you can understand the relation between electricity consumption and human mobility. This is totally open code. You can go on the link and work it, run it. The Apple changes the data source constantly, but you can just Google it. But what we need to check here is that if we are at home, residential means home here, so our electricity consumption is much lower compared to normal times. It's minus. This is very true, because the total electricity consumption is always much lower when everyone is at home. Of course, the consumption of the household increases, but if everyone is at home, then it means we're not shopping, we're not in transit, we're not in retail, we're not in parks. So there is a minus consumption. So during COVID, we can have many different information on the lifestyles of Turkish people and transfer that information to other places. So let me now talk about digital twins. It's considered as a commercial definition, but it's not that commercial. European Union started a project called Destination Earth, and at the same time, they will be looking at the previous data, making a modeling, and then with the real data, they will be constantly updating this. They will be focusing on farming, energy, disaster management, disaster risk management, and climate change. They are trying to gain benefits in all these fields. I'll give you some information from a real study conducted in Turkey. There is a 100% correlation between lightnings and electricity outages. In Turkey, during many electricity outages, if instead of the satellite data, if people were using the local stations data, if we had a digital Turkey, then it would be much better. For instance, according to the showers and how they proceed, maybe we will be able to see 10, 15, 30 minutes before where there will be a lightning and where there will be an outage. And maybe we will be able to reduce the number of people in Turkey who are affected by floods. So for digital twins, my suggestion is that, by the way, most probably these digital twins most probably will be very beneficial, and thanks to these digital twins, we'll be able to see many scenarios 2 hours before they happen. So ENSUE works the digital twins all the time. So the grid, before you start consumption, has many simulations. So why not do it in real scale? I think in 2050, all distribution companies in Turkey will definitely have to have digital twins in place, just like the grid models. So they will need to integrate all the events or incidents in their regions. Digital post offices, as you know, the Ministry of Commerce started a joint platform for messages. You can log in and see all the platforms that can send you messages, and you can untick and remove those platforms, for instance. Previously, it wasn't like this. Everyone could send messages to anybody else. So, our digital IDs are far ahead than our real IDs. So it's going to be very important to manage the digital IDs. And we have, for instance, hash codes, CINAM codes. So to restore our personal data. For instance, Yemek Sepeti most recently was hacked, so people's names, phone numbers, consumption habits, anything, you name it, was stolen. So it's such a public platform that after a while, most probably, people's personal information will be stored in a digital post office. So maybe you will be able to choose who can access your personal information like your phone number, name, etc. Second thing is that what we call as AI is all about matrices and numbers. So we have static matrices, numbers that are multiplied, you enter the data, you come up with conclusions. But what if instead of numbers we were using probability curves? And this could actually give us many opportunities that you can do with quantum computers. Meaning, the likelihood of an electricity crisis is not 50%. At the same time, you can compute through probability curves when the outage will happen, at what time, for how long. So it's like an AI algorithm. This is evidential deep learning. There are many examples like evidential deep learning. So what we are asking from AI is maybe not only numbers, but it's also probability universes. So it's also very meaningful in terms of consumers. For instance, what will be the curve of electricity consumption of the consumers in a given area? We can see this. So virtualization, this is from the works of an academic published in IEEE. This is virtual traffic lights. Well, I read the article and I liked it. I asked myself initially, why would we have virtual traffic lights? But if you have all this data, this computing power, then you can virtualize any asset that you are seeing. Just like creating digital twins, you can also create this. In the electrical system, everything can be virtualized. But it's different than the digital twin. Every plug in your house can be a different subscription point. Like your subscription number is 37, right? One plug can be called as 37.1, 37.2, etc. And all these plugs can behave like consumers and trade, and they don't need to do it physically. Instead, by the way, the grid, electricity grid, doesn't see the physical asset, but it sees the reaction in the grid. So you can actually virtualize that reaction. So these are the things that are available. For instance, virtual inertia is something very, very important for grid security. Then we have virtual power plants. We have seen it before. And what about virtual consumers? For instance, if consumption is very high, you can have certain points that should get that consumption. For instance, at that time, industrial facilities might consume more electricity, or the self-generation airports, for instance, the entire grid might be taken off the system. So you can have consumer demands changing on real-time basis. Because all these things are possible, because we have the data, we no longer have the human element. Instead of humans having checklists, we have algorithms and virtual platforms that feed with data. Maybe we will have virtual transformers and lines and virtual capacities. Maybe this is going to be important for charging stations. In Istanbul, for instance, it will be more important to manage the virtual capacities. If we can digitalize something, then you will definitely have the virtual version of that. So the more actors we have in the grid, the more flexibility and security we will have. And there is also, of course, going to be cyber security. One of the most important things is that we have a very basic function. What is the optimal duration for a consumer to think about the electricity services? Maybe 1 minute. They receive the bill, they think about their electricity consumption, that's it. But maybe the consumers shouldn't even have to think about their electricity services. Just like Apple iPhone, Google, the consumers can use an app that will provide the answers to them only when they want. If they ask the question, why is my bill that high? So instead of disturbing the consumer all the time, you can have a system that can bring all the data to the consumer whenever they want it, so that the consumer will no longer have to think about these things, but will get their power at the lowest cost and be able to sell their solar power, for instance. So we need autonomous systems for this. Think about it this way. When you have autonomous cars, to what extent will you have to think about the road? No, 1% maybe. But if you're not in an autonomous car, you have to think about the road at all times, right? So this is my last point. Humanless energy services is something we need to think. Imagine the automobile revolution from T model to Tesla. It wasn't the car that mattered, but it was how it was manufactured. Automation reduced the car prices all of a sudden so much. In textile sector, it was the same. There was a shift from human to machine, and in telecom also infrastructure. We previously had switchboards. We no longer need them. So what about the energy services, distribution services, customer services? Why do we still need humans? Imagine we removed all the human elements. Is there a pattern? If there is a pattern, we can remove the human element. This might sound like an evil thing to you, but this is how the system is evolving. So virtual assistants can be assigned to field services. Just like having virtual drivers, etc., we can have these humanless energy services provided. And this is how the world is evolving. Most recently in the oil and gas sector, it was revealed that with the automation sectors, we can have a 20% reduction in employment. This is my last slide. By the way, the future is an ongoing discussion, so if I were to deliver this presentation next year, this would be a totally different presentation. But the most important thing is not about an Industry 4.0. The important thing is to identify the vectors. What's our direction? So we need to come up with patterns that can copy or mimic humans. And this AI is not the first generation. It's maybe fourth or fifth. It's been there since 1960s, but this is not the last. It's going to be the 9th or 10th generation. And it's possible to eliminate human factor, just like Tesla and T model example. You can copy all the things that can be done by human beings. And you can also have more insight about human beings than the humans have about themselves. So as long as you identify the patterns, you can do this. And then virtualization of assets is important. Imagine oil is being traded virtually nowadays, and many virtual products in the system are priced in virtual ways, and this can happen in the energy sector as well. Thank you very much for your patience for this long presentation. Thank you. We would like to thank Mr. Barış Sanlı for the valuable information he has provided. It has been inspirational. This marks the end of our workshop today. We would like to thank all of our speakers once again for dedicating their valuable time to us and express our gratitude to you, our distinguished participants, for the interest you have expressed to our event. You can access the video recordings of the event and detailed information about the speakers through the event program on the digital platform and the www.enerjietkinlikleri.org website. The recordings of this workshop will be available on the digital platform until May 29th, 2021. Finally, I would like to state that we look forward to welcoming you at our final event, titled the Forum on Energy Sector Program Phase 2 Energy Efficiency Projects, which will be held on May 5th, 2021. Hope to see you again. Goodbye.